Okay, the new lesson today is logic gates. So we are going to learn about the logic gates, and here actually we are going to learn about. So this logic gate lesson is very important because so it explains how computer works. It explains the fundamentals of computer electronics. So computer is electronic device. So actually, so it's working according to the behaviors of the switches and bulbs. So basically I'll explain how, because so when we input something, keyboard, when we input some key, so that key is considered as a switch, and when we output something to the monitor, so it is considered as a bulb, right? Keys and bulbs. Okay, so let's learn the fundamentals. Let's learn the basics or the fundamentals by exploring the logic gates, right? Let's learn the fundamentals or the basics by exploring the logic gates. Why I'm telling this logic gates is the fundamental for computer or fundamental for computer electronics is because so when you study how these bulbs and switches works, when you study how these bulbs and switches works, it clearly shows the behavior of your monitor and the keyboard, right? Okay, so before we begin, I would like to introduce you a small website, right, where you can use this continuously to learn the logic gates. So let me introduce that and I'll send you the link. That website is none other than this logic.ly/demo. So this is actually this is a paid tool. You have to buy this, purchase this, but there's a demo version or online version. The cost of this tool is like $59 per, I think, per the license, per single license. You have to pay $59, but no need to buy this because you can use the demo version or the trial version for this. I'm sending this to your inbox and you can just log into that. Okay, before we begin, let me explain the behavior of switches and bulbs. Okay, I'm going to take few bulbs. This is interactive. You can also do this with me, right? This is interactive and you can also do this with me. So let's take some bulbs. I'm going to take few bulbs. Let's say 1, 2, 3. I have taken 4 bulbs. Okay, let's take some more. You could copy and paste the same. Now we have 8. And let's copy and paste again. Now we have 9 such bulbs. Okay, so let's take another 3 to that side. Now altogether we have 15 bulbs. And I'm going to use some switches. So let's use, no need to use all 15 switches, but I'm going to use some switches here. So let's use like, no need to use 15, but let's use some switches. Let's use 8 switches. And I'm going to connect these switches to bulbs. So this one, you can do this with me, right? 2, 3, 4, all 8 I'm going to connect. Okay, this one. Okay, let's use 15 switches. So it's not take much time, not just that. Few more switches. Now you have 12 switches. Treat these switches as your keyboard. These switches shows your keyboard. Let's say this is your keyboard. You have 12 switches here. And so this is without the logic gates, right? This is without the logic gates. So this is not logic gates. This is basic switch and bulb case. Don't treat this as a logic gate lesson. Okay. 3 more switches to connect these bulbs. 1, 2. Forget about the wiring, otherwise you will like confuse with the wiring. Okay, let's see. These are switches and bulbs. And I just want to show these bulbs indicate your display monitor. These switches indicate your control room or the keyboard. Earlier days, this was in generation 1. This was called control room. First generation computers, I think you have heard of. So this is called control room, but now it's like very small. Now it's your keyboard. You can keep it in your palm. You can keep it in your lap. So that kind of small thing now. But earlier days, this control room was like a garage size control room. It's a very large room. But now it's very small one. It's keyboard. And let's say I want to display like, okay, I want to display something. Okay, I want to display letter C in my monitor. So what I have to do is I'm going to turn on this one. 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 I think you have seen this in these LED boards. Okay, and I'm going to turn on this one also, and this one and this one. Okay, this one and this one. Okay, I have turned on these bulbs. So in additionally, I can, if you want, I can turn on this and this too. Okay, let's see this from far away place. Let's see this from far away place. So just zoom out this. And if you see the bulb pattern, so if you see the bulb pattern, let me draw on top of that. So this is the bulb pattern. So this is how you turn on the bulbs. And if I draw that, you can see it's, what is that? It's letter C. It's letter C. If you see this from far away place, let's assume the turn off bulbs are hidden. Turn off karapu bulbs hide karakele hitamu. And let's assume these switches are also hidden. So switches are nicely covered like a keyboard. These bulbs are nicely covered. And then you can only see the bulbs which are turned on. So that will create the letter in this monitor, that is letter C. So this is the fundamental. That's why we are learning electronics in computing. This is the reason for teaching electronics in computing, right? Okay, so let's zoom that back. And actually, this is not logic gates. So I just explained the reason to teach this logic gate lesson in A-level ICT. The reason to teach logic gate lesson in A-level, these LEDs are, so these bulbs are now actually, it can be LCD, liquid crystals, it can be LED, light emitting diodes. So likewise, but you have like here horizontally in your monitor, you have closer to 2000 such lights. And vertically, this direction, you have closer to 1000 such lights. So you will not see individual lights, but anyway, you will see this kind of, so ultimately, it will create letters and it can create graphics even. So let's say you have turned on bulbs in this way, and I'm going to do something like this. Let's turn off everything. Even graphic can be shown this way. Okay, let's say you want to show, right? You want to show something like this. I'm going to turn on this. Then just turn on this. And the top one. Okay, and then these two. And this one also. Okay, this is like a, if you draw this is like a graphic. This is like illustration or graphic. This is not letter. It's an illustration. So that's why we are learning electronics, right? This is similar to your monitor, and this is similar to your keyboard and other input devices, mouse, whatever you name it. Okay, now let's go to the lesson. Now you know the reason for learning this electronic lesson. So now please write down the heading. Please write down the heading logic gates. Please write down the heading logic gates, and under that, so you don't want to write the Sinhala note. I just added Sinhala note because I'm doing Sinhala medium class and English medium class both. That's why the Sinhala medium note is there. But you don't want to add that. You can write the English medium one logic gates, and under that, please write this logic gate and explain the logic inside the electronic circuits. So that is the simplest way to explain this. Logic gate explain the logic inside the electronic circuits. Right? To instruct these logic gates, we are using the machine language. To instruct the logic gates, we are using machine language that we will be learned later. And there are three basic logic behaviors. And under that, the first one, please write, that is OR gate. Under that first one, please write OR gate. So just write the highlighted things only, which is highlighted in blue color, please write. No need to write the other one. Logic gates. Logic gates explain the logic inside the electronic circuits. And there are three logic behaviors. The first one out of that is OR logic. First one is OR logic. The first circuit is electronic circuit. The second circuit, actually, second one is not circuit. This is for the girls. So I have used like think this as a water barrel, and this think these two as these two as taps, water barrel and tap. So if this is the tap line, if you want to take water from this barrel, if this is a tap and this is also a tap, opening this tap will also drop water to you, also deliver water to you. So if you open this, you can get water, right? So if you open the second one, still you can get the water. If you open both, still you can get the water. But if you close both, then no way to get water from the barrel. Okay, similar to that, if there's a bulb and battery, okay, let's draw this quickly. I think we can draw this and see. So we can use circuit construction kit. Circuit construction kit, this one. Okay, I'll send you the link of that as well. If you want, you can just go and do this with me. Okay, I have sent the link. If you're joining using a mobile phone also, you can do this, right? Okay, let me take the introductory one, and this is the lab. And so let's construct the same circuit. This circuit has a bulb, two switches which are parallelly connected, and the battery, bulb, and two switches which are parallelly connected to the bulb using some wires. This one, disconnect this end. And let's use another wire to connect this end. You have two switches, this one as well as this one. Okay, now if you want to turn on the bulb, so this minus sign is electrons. If you hate electrons, you can hide that. You can show the conventional current power. Now these are copper wires, right? In these copper wires, basically, to bulb to be turned on, if you want to turn the bulb, this is the plus, but this plus voltage should be connected to the minus voltage. It should go through the bulb, then only you can see the lighting effect in the bulb. Actually, if it is electrons should travel the other way. Electron density is high in the negative edge, electron density is low in the positive edge. Density එක වැඩි තැන ඉඳන් density එක අඩු තැනට ඔයගොල්ලෝ දන්නවා විසරණය කියලා නේද? Density එක වැඩි තැන ඉඳන් අඩු තැනට. So the place which has higher density to low density, electrons should travel. If electrons can travel, here electrons can travel, then you can say the conventional current will travel the other way, the opposite directions of the electrons. Electrons travel this way, this side, electrons travel this side. The conventional current traverse the other side. That is how we explain, right? Anyway, so whatever electrons or conventional current, forget about that. Forget about conventional current or electronic. No need to show the current. But anyway, you can light up the bulb simply. If you turn on this one, still this is connected to this path. Still you can lighten up the bulb. If you turn on both switches, still bulb, you can lighten up the bulb. Let's turn off this and this both. Now no way to send the electrons because path is incomplete. When you come here, no way to go. 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 Then, so you don't have a mechanism to lighten up the bulb. So that is the O logic. Simply, that is the O logic. So remember that you can't go and buy logic gates from a shop. You can't go and buy a logic gate from shop because those are not available in shops. Simply. So what you have to do, you have to implement the logic. Those implemented logics are there inside ICs. If you buy IC, so let's refer to this. I'm going to open something related to you, but actually not related to your grade in the book. So I'm going to open, let's say grade 10. This is O-level ICT book, but anyway, so this can be explained, even explained using O-level ICT book. That's why I'm opening this. So when you go to the page number, okay. Okay, see this. So inside IC, you have these logic implementations. Inside IC, you have this logic implementation, and that's why that's how we can buy a logic. We can't go and buy I need AND gate, I need NOT gate, no. But you can buy IC. Inside this IC, you will see this logic. Inside the IC, you will see this logic, and that's how it's really implemented. And inside IC, actually, it is implemented using this kind of switches, transistors, and all. So that is in depth, but no need to know up to that. Anyway, now you learn the behavior of OR gate. What is the behavior of OR gate? So this word is very, very important. If both switches are open, then the bulb will not turn on. And I would like to highlight this sentence. This is in red color because it's very important one. Right? This way you have to remember the OR gate, right? This way you have to remember the OR gate. So first of all, you can draw either this one or this one. I prefer electronic circuit, right? So please draw the electronic circuit and then write down this one. If both switches are open, then the bulb will not turn on. And this is the symbol shown in the particular OR gate. So please draw this one, write this line, and draw the symbol also, right? Quickly do this. Right. Truth table explain, right? Truth table explain the logical behavior using binaries, right? Truth table explain logical behavior using binaries. How? Basically, so when switch is turned off, the status is 0. Switch is turned on, status is 1. So try to understand, these are basics, but if you cannot understand the basics, please ask again, right? Because in future, because this is only very basic lesson, the first lesson. But in case if you cannot understand the first lesson, what will happen? Future lessons will be very difficult. That's why I'm asking. Okay, 0 වලින් පෙන්නන්නේ off status. 1 වලින් පෙන්නන්නේ on status. Okay, both A, B is closed. Both A, not closed, actually, switches are not working. Let's say switches are not working. Both A switch and B switch not working. That is the only case the bulb is not working. That is the only situation the bulb which doesn't work. And all other situation, if B is working, bulb is working. If A is working, bulb is working. If both A, B working, then also bulb is working. So this is the very important point. OR gate will output 0 if and only if all inputs are 0. If all are 0, so assume that there are 3 switches. So let's go and change this to 3 switches. So if you have 3 switches, still the case is same. Still the case is same means if you have 3, if all 3 off, bulb off, එකක් හරි on, then 1 on, you can see 1 on, bulb is on. එකක් හරි on, otherwise the bulb is off. Here both are on, bulb is on. All 3 are on, still bulb is on. 2 off, but still 1 on. So you have to maintain that. At least if one, so rather than telling that, the easiest way is if all are closed, if all switches are in the not working status, if all switches are in the not working status, that 0 status, then bulb is off. But all other occurrences, it's on. So please write down the truth table and show this too. Right. The next one that we are going to learn is AND gate. Next one that we are going to learn is AND gate, and this is the opposite behavior that shows opposite behavior to the OR gate. So you can see this is the water barrel and you have 2 taps sequentially. So if you turn on this tap, still you cannot get the water because this is blocked. So if you remove this block and this block too, both, if you remove this block and this block too, then both taps are open, then water will flow. Water will flow out. And that is the nature, right? So that is the logic related to AND gate. You have sequentially connected switches here. If you turn on both only, if you turn this switch both on, then only the bulb will lighten up. You can see in this circuit. So here, if you have at like